So welcome again, guys. Today is our first session, and what we are going to do is today we will deep dive into introduction to AI and machine learning. Okay. So before that, I will just give you some small introduction what we are going to do as a part of this particular course. So this course basically we will learn how to use LLMs, right? Large language models to build applications like chatbots, intelligent assistants, agents, and things like that. We will see what is the capability of these LLMs. First of all, we will see what are these large language models. We will we will also see the basics, what is machine learning, what is AI in general, and then we will understand how these LLMs works basically and how we can use and exploit these LLMs to build some applications like chatbots. Okay, so that is our primary goal, and we will be using Python most of the time to build such applications which can make use of large language models. On the other hand, there is something called as a LangChain. Okay, so LangChain is what? LangChain is again a framework which will help us to build such applications with ease. Okay, so that's why we will deep dive into LangChain, how it works, what are the different modules in it, how we can make use of LangChain to build these applications more efficiently and more quickly. And then this course for with each of these sessions, what we will have is we will have some theory plus some hands-on exercises as well. So we will build some applications. I will give you some assignments as well so that you can also try at your end and you can build those applications yourself as well. Okay, so this is the very basic introduction on what we are going to cover. Any questions from anyone? Feel free to ask, guys. And I think in the last session, I also covered the details, what are those 14 sessions which I'm going to cover, agenda for each of those, right? So I think I will not be going across that same. So today we will focus on the very basics of AI. We have been hearing, about artificial intelligence and machine learning for quite, I mean, in fact, some of you must be working in the field of AI as well, right? So this is just to give you a brief introduction on what AI is in general and what is the difference between AI and machine learning, what is deep learning, what is neural networks. So if you have not been working, then I mean, probably you may get confused, right? What is the difference between these two things? So that's what we will try to understand. So as I said, in this module, we will be exploring the fundamentals of generative AI. Then there is a new concept of generative AI, Gen AI, right? So we'll also see what is LLM and what is Gen AI, how they are related. Okay. And our primary goal for this module, the first lecture, is to understand how large language models works, basically, how they are trained, how they generate the completions. Okay. Having knowing how these LLMs basically works, how they are trained, how it will help is it will not help us to build the applications, but at least it will give us an uh, idea. It will give us some notion that how we can use them and how under the hood they basically work, right? So that's why we are going to deep dive into LLMs, how they are trained, and what we should expect from the LLM and what we should not expect from the large language model. So it's not a magic wand which can do anything for you, right? So it has its own limitations. So we have to be aware where we should use these LLMs, where we should use some other tools, right? We have to learn how to make right choice about using them. Also, it if you know how these LLMs work, basically it basically helps you to debug and understand the non-deterministic aspect of these models. right? So as I said, they are not magic wands which can do anything you want, right? So we should be aware of their limitations, their non-deterministic nature, and knowing how they basically work will help us to debug our applications as well. All right. So our primary goal is to understand, to solidify our concepts regarding large language models, which will be valuable when applying these models to our applications. End of the day, we are going to build applications which are based on LLMs. Anyone has any questions so far?
So what is the generative AI in general?
Yeah.
Where it fits here?
So that I'm going to cover right now in this slide. Okay. So in fact, before understanding what is generative AI, let's first understand what is AI in general. What is artificial intelligence? Anyone from you guys would like to? So, I mean, I want this session to be interactive, right? So that I can also understand what is your, your level of understanding, what is your thought process, and that will basically help me to explain the things in a better way. So, anyone of you would like to describe what is AI, artificial intelligence?
Definitely, we can keep the session interactive, but I suppose,
Mm-hmm.
like for
Mm-hmm.
me, I would really like to understand the basic definition and differences between ML and AI,
Mm-hmm.
because for now, these are just words for me or jargons,
Mm, correct.
right?
Mm.
So, I would really like to understand the difference and maybe with some real life examples or so that I can remember it.
Mm-hmm. Got it.
Hey, Surendra.
Yeah.
So motive from this session is like we know it's a buzzword into the industry and a lot of transformation over the period of this time, like going on from last 1 to 2 years, and maybe in
Mm-hmm.
future.
Right.
IT jobs are more focused on to the AI, but looks like industry is a little bit confused how to, I mean, they are confused like, okay, hey, we know how to use these models
Mm-hmm.
and compare it to use the tools based on it. Like everyone is expecting to use from the developer perspective to use the Copilot or some other, Gen AI tools, okay, or agentic tools.
Correct.
But I think there is another stream that what we are going to, learn into this, how to use, how to program, right? That's a totally separate stream.
Mm-hmm.
Like, okay, we are going to work on to the AI to use the models. But on the other hand, people are like more, hey, how you can make your productivity or how you can be boost up your productivity, whatever you're supposed to do it within 8 hours, how using these two to use Gen AI tool like the Copilot or Codomerge or anything, right?
Mm-hmm.
How you can do it faster. So that is a one aspect from the developers, not like writing the code into the, yeah, that is totally different thing, but they are not expecting you to write these AI ML languages or programming, but they want you to use the Gen AI applications, right, into your program or find out the use case and how you can, use the tools based on these AI ML. Am I right here?
Yeah, I mean that's correct. But this course is more oriented towards how you can build those applications. I mean, this is
Mhm,
fine that these days even a developer has to make use of these services, right? They are going to use the ChatGPT or they are using the Copilot. They are
mhm,
having the plugins with their VS Code with the help of which they can code faster. But I mean, that's a separate thing. But this course is mainly concerned with how to build, how to make use of large language models and their APIs to build some applications. Right.
mhm.
So this is more from the developer's perspective rather than, from the consumer's perspective. Okay, so I will
Got
tell you how you can use OpenAI's APIs to build the applications, how you can use uh, Perplexity, how you can use your free source models, open source models like your Code Llama and Gemma and others, right, which are hosted on some other platforms. So for example, on Grok we have a lot of open source models. So in this course I am going to tell you how you can make use of those APIs, how you can build your applications, how you should configure your environment. Definitely I will also tell you how you can plug in your Copilot with your Microsoft Visual Code, right? So all those things which a developer needs to build any application, that's what the main agenda is. I mean, that's why the course is this much long, right? For 12 to 14. It's not merely how you can make use of the AI stuff to, to utilize your 8 hours in the office, but this is more from the developer's perspective. I hope that makes sense, right? I
Yep,
mean,
yep, yep.
some of the things which you have mentioned, how to use copilots and other things to make the maximum use of the 8 hours, that those will be definitely covered somewhere in the course. But the agenda is to make you efficient, to make you aware of the LangChain like frameworks and what is their syntax, what are the different modules, how to build, some POCs using Streamlit. So there is one session on the Streamlit as well, which is widely being used to create user interfaces very quickly, and then you can put your code and you can make something, create some chatbot in few minutes. So that's how I look at this course.
That
Got
is
it.
that is good, Surendra.
Hmm. I think I lost you. Can you guys hear me?
Sorry. Yeah,
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 yeah, yeah.
yeah. So, only thing what I see is
Mm-hmm.
like I am not a developer,
Uh-huh.
right? And do not have Python basics or anything.
Mm-hmm.
So probably I need to have some. Uh, I need to learn Python also,
Correct.
right? To
Mm-hmm.
understand even the basics from all those things what you mentioned.
Mm-hmm.
That is definitely going to be right, good.
Mm-hmm. Exactly. So this
it's
is
not
definitely.
only it's not only
Mm-hmm.
about learning how to use prompts, right?
Mm-hmm.
Otherwise means why we are doing this course.
Mm-hmm.
Maybe we would have you viewed some YouTube videos or some short courses which are there in our organization also, internal
Mm-hmm.
intranet. So definitely this is going to be very effective. uh, but yes, probably we would need that from basics, like
Yeah,
Python
yeah.
basics and all.
Correct. So I
So
will
that
cover
will be an
some
extra
Python.
efforts for you. Yeah,
Exactly. So I will cover some Python basics as well, right? So that's what I
thank you.
mean. I mean that's why I said there is no as such prerequisite for this course. If you know any one language like C or CPP or maybe Java, then it's sufficient, right? More or less the concepts are same. In fact, Python is one of the simplest language to learn quickly and one of the most strongest language as well. I think the number of users who are using Python is now um is at number one basically. It's the most widely and the most effective language as of today in this era, right? So I would not say you should learn Python only for this course, but even if you are not doing this course, if you are in the IT industry, I think knowing Python is a must these days, right? So that is going to help you in the longer run anyway, Python.
Yeah, yeah.
So I mean, earlier I used to do a lot of stuff using Java, but when I started using Python, those things which I was doing in maybe 15-20 seconds, Python can do it in 2 or 3 seconds. So even I was surprised, the way Python works, and it's so efficient as long as I mean, as long as machine learning or these NumPys, Pandas, these packages are very efficient packages which can make your life very easy. So yeah, Python is definitely a must for this course and in general as well these days. So let's go back to our agenda. So what is AI? So AI, uh, one of the simplest definition is the effort to automate intellectual tasks normally performed by humans. Right. So this definition may look very broad, but it is broad. I mean, by intention, right? If there is a system which is doing something which usually a human being would do, then we can say, okay, this is an AI system. Okay, so This definition is very broad. This is very open-ended, and there are no as such rules and regulations that this is a AI system or not. You can just think from the perspective that anything which mm, actually need a human being to think, if it is being done by a machine or by a system or an application, then we would say this is an AI application. Okay, so this is a very broad term, and this is not something which has emerged in the last 2 or 3 years. In fact, AI term and the AI itself is in place for the last 75 years. You will be surprised to know this is in industry for the last 75 years. In early 1950s, so we have been using AI in some or the other form. Okay, so this biggest circle which you see is actually AI. So anything inside it, machine learning, neural networks, deep learning, generative AI, LLMs, all these are part of the artificial intelligence. Okay, when we say we are using machine learning and we are able to predict something, for example, let's say I want to predict the price of a house. And if I have a data for the price of the houses for the given, let's say 1,000 houses, then what I will do is I will train my model to learn the pattern within those 1,000 given data. And then I will be able to predict the price of a house, right? Similarly, there is something called as a neural network. There is a deep learning, there is generative AI. So all these are nothing but part of the artificial intelligence only. So this is one way of looking at artificial intelligence. The other way is from the by the way we actually use, by the way we use or design our applications. For example, there is something called as NLP, which is natural language processing. So in this field, we basically concerned with processing some text or the natural language data. That can be text, that can be audio or video, where there is a natural language, the language which we usually speak, right? So this is from that perspective. This is NLP. Machine learning, as I said, it has other parts. For example, it has deep learning, it has generative AI. So let's talk about all these things one by one. So machine learning, as I said, is a stream where we, we learn the pattern of the given data, and based on that pattern, we predict the result of something which your model has not seen in the past. Right? As I said, if you have prices of 1,000 houses, then what you will do is you will make use, you will take some algorithm, and then you will train your model with those 1,000 data. The model which is being generated basically will do what? It will learn how the prices fluctuates, maybe with the number of rooms, maybe with the locality, maybe with the size, right? Area, all those things. And then it will devise some equation or some model, which when you input the features for a house for which you want to know the price, then it will be able to tell you the price of that house. Okay, we will discuss more on this example, but I'm just giving you the very high level overview. Then there is something called as a neural network. So neural network is also a machine learning where we basically train our models, but instead of using the conventional machine learning algorithms, we use something called as the neurons. We basically have different layers. I will explain you. So this is an example of neural network. So what we try to do is basically we have different layers, and this is something, this is called as a neural network because this is being inspired from our brain. The way our brain works, right? We have neurons in our brain and they get activated or once they get the signals. So maybe at one time this neuron get activated and it will activate other 3 neurons, and these 3 neurons may activate some other 5 neurons, like that. That is the only similarity. Otherwise, there is no as such similarity between our human brain and the neural network. Okay, don't think that neural network is something which works exactly same as the brain. How the brain works, even researchers don't know. Even today, they only know maybe 5 to 10% how the brain works. But yes, it has been inspired from how the brain works, basically. That's why they have taken the term neuron. So it's like saying, the birds and the planes are similar. Okay. They are similar in the way that they both can fly in the sky, but there is a lot of things which are not similar, right? Plane is made of a metal, and whereas the birds are living organisms, this is a non-living organism, right? So there's a lot of things which are not similar, but yes, both fly in the sky, both have aerodynamic design, both have wings. That's the only similarity, right? So this is how the neural networks works basically. So I will deep dive into this in the later slide. So that's called the neural networks. When the number of layers, right? As I said, you have multiple layers. You have an input layers and you have an output layers, and between input and output, you have couple of more layers. When the number of layers increases, there is no as such a standard number, but if it is more than 8 to 10, then we start calling it as a deep learning. Deep learning means when the neural networks are very deep, in the sense they have lot of layers in it. Then we start calling neural networks as a deep learning or the deep neural networks. And then when we talk about generative AI is something where we are actually generating some new content. That new content can be new text, that can be new audio, video, images, anything. That field or those models which can generate some new content, that is called as the generative AI. Because let's say you say, I want to create an image of, a mouse which is uh, running on the moon, right? So this is something new. So whatever image it will create from this prompt will be something which our network or our model has not even seen in the past, but still it will generate something which is the first time it has created and the first time we will see. So it generates something new which has not which it has not seen in the past. Okay, so that is called generative AI. So within the generative AI also we have some models which can generate images, some can generate audio, some can generate video, and some can generate text. So we are mainly focused with the text one, which is called large language models. And these days, these large language models are also multimodal, so that they can do multiple things, right? You can create images as well. You can interact with them in the audio mode. So they have those capability. That's why these models are also called multimodal models. Okay, so that's the last layer, which is large language model. So this is a high level overview. As we deep dive into the course, I will try to have one session where I can show you how to train a machine learning model. In the next session itself, I will show you. I will show you some piece of code. We will run that code, and I will show you how to train a model. Okay, let's say in order to predict the price of a house, we will train some models. Similarly, in case of the neural networks, where the so so there is a usual question, right? When I should use machine learning, when I should go for the neural networks. Okay, so when the problem is a bit complicated, for example, we need to analyze some image, right? Or my input features are more than 100 or more than 200 thousands of features are there, then I will generally use neural networks because they are more efficient. Okay. So I will also show you how to run some code. I will run some code and I will show you how it can process a image. Okay. And deep learning is also part of neural network. When the number of layers increases, we start calling it deep learning. Generative AI, anyway, we are going to use throughout the course. Does that make sense?
Yes. Can you please repeat the definition per se for LLM?
LLM, large language model. So
Yeah.
large language models are basically the models. Okay. Models, for example, when we train a model which can predict the price of a house, that is also a model. Similarly, when we make use of deep learning, or we have, I mean, there is something called as transformers architecture. So that transformer architecture is also made up of some neural networks. So when we train or build that kind of model which is based on transformers architecture, So, I mean, you may not be able to understand at this point. We will discuss the transformer architecture also later in this session. But when our models are based on transformer architecture and we train our models, okay, they are called large language models basically, because
Okay.
they can process the language, the words which we speak, the text which we can write. If we give them as an input to these LLMs, large language models, they will be able to understand that particular sentence, and then they will be able to reply. Okay,
Okay.
we will see it in more details. Okay, see, a lot of things are actually interdependent, so I may not be able to explain you each and everything with that ease, but gradually with the course, you will be able to understand all these things. Okay, so another thing is, when we say artificial intelligence, as I said, anything which can mimic the intellectual or which can mimic the human being's behavior, and when we try to automate something which in general would need human brain or nature, then we start calling it as an AI. For example, predicting outcomes and recognizing patterns based on historical data, right? So we have taken an example of predicting the price of the house. So in that case, what we are doing is we are predicting outcomes and recognizing the patterns based on some historic data. Let's assume there is a person who is a property dealer, right? In our layman's term, he knows what is the price of the houses in the nearby areas, right? He can tell you in Delhi what is the prices of house in the Karol Bagh, maybe in the Chandni Chowk, and all those things. Only because he knows the price of various houses in the past. He has some experience in that field. Similarly, when we train our model, what it will do is, based on the data which we feed into it, it learns the patterns. Okay, if there is a house which has more number of rooms, will obviously cost more. So it knows the pattern. Okay, this is directly proportional. Number of room is usually directly proportional to the price. Then we will say there is a house which is located near some hospitals, maybe near some schools. Then it will learn, okay, if such facilities are there in the surrounding in that area, then usually the price of the house will increase. If there is a Delhi metro connectivity, or the metro is very close to the house, then definitely its price will increase. So these patterns, it basically learns from the input data. And then when you say, okay, I have a house, it has these many rooms, this is the area, this much far it is from the hospital, you now tell me the price, then it will be able to tell you the price. So that's what is called machine learning, and machine learning, as I said, is a part of AI. So now you can, start building that concept. Okay, this is not a very straightforward problem, right? So it needs some kind of intellectual, in terms, a human has to think, okay, what should be the price? You start some processing, right? You know if the number of rooms will increase, then definitely the price of the house will increase, like that. Recognizing abnormal events and making decisions, right? So this is also not a straightforward problem. If you have a lot of data, lot of, uh, abnormal events in the science, let's say, if we are using our credit card, usually if I'm in India, I will use it from morning 9 to maybe 12 in the midnight. If there is a transaction which has happened maybe at 3 a.m., then definitely it will raise an alarm, because usually that's not my pattern is, right? That's an abnormal event for me, doing the transaction in the 3 a.m. in the night. I have not done such a transaction in the last 10 years. So how the system learns? It learns from your history. It knows this is your pattern. You usually make maximum number of transactions at maybe 11 a.m. or maybe 8 p.m. in the evening, right? So if you suddenly do some transaction at 4 a.m. or 3 a.m., it will raise an alarm. This is an abnormal. The timing will go out of the range and it can raise an alarm. Okay, interpreting visual input, it's not easy, right? When we see a dog, we are not trained, or we don't train our kids telling them this is a dog, this is a buffalo, right? They learn from their visuals on the daily basis, right? Similarly, we can build the machines and we can train them with lots of images, at some point of time it will be able to understand, okay, if the ears are if the features of the input image are like it has uh, the eyes in this shape, it has long hairs, it has ears, it has this kind of nose, it has four legs and something like that, then what it will do is it will start interpreting the visuals also. This is how the driverless cars works, right? They have a lot of sensors, they see what is in the front, right? How far is the car, is that a car or is that a human being? Then it will also calculate the distance and then it will take some action, it has to press the brakes or what, right? So interpreting visual inputs, image analysis or image classification, whether it's a cat or a dog, like problems. So all these are basically examples of artificial intelligence where in general we will need some human intellectual to decide. Okay, I hope that has given you some impression on what is AI, understanding language and engaging in conversations,
Yes.
Yeah.
extracting information from sources to gain knowledge, things like that. So everything is AI. If you think from a perspective, if it would need human being in general to solve that problem. So let's talk about some brief history of the artificial intelligence. As I said, this is something which is not new. This is there in the industry for the last 75 years. So, but in the earlier days, what they used to think is the AI was more like a rule-based systems or some symbolic AI. The name was given was symbolic AI. So in that AI, what happens? The thought process was we can create some if-else rules. If this is the thing, then it has to do something, right? If else type of conditions. If you write many if else conditions, then maybe they thought the program or that application will be able to mimic a human brain, right? For example, a human brain has a lot of information, right? So the earlier thought process was if we create lot of millions of rules, okay, we create a rule book, such a vast rule book, then one day they should be able to create some application which will behave just like a human being. Okay, but it was not successful because they can work only in a very controlled environment. Then it will basically works. Otherwise, it will not work. For example, if you want to predict the price, what you will do is you have number of rooms, you have a square footage, and you have location. Location you can take, some score. Maybe the best location is 10, the worst location is 0 to make it mathematical, right? 0 to 10 scaling. So if you have this problem, these things are actually called features. Number of bedrooms, square footage, location on which your price depends. These are called features. And these are basically weights, W1, W2, and W3. So what they thought was, if there are prices of some 10, 15, or 20 or 100 houses, what they can do is basically this will become an equations, right? Mathematical equations, and you have to solve those equations and you have to find out the value of W1, W2, and W3. Those weights which will satisfy most of those equations, right? So it was basically a manual process, or it was basically rule based if else condition type of thing. So in 90s, or maybe I think 95 or 97, using rule based AI, what they did was they created one deep blue chess playing computer. Okay, that was based on symbolic AI, and that game was able to defeat the world champion of the chess. I think Gary Kasparov was the world champion at that time. So this system was able to defeat him, and that system was basically based on rules. Okay, so we have lot of pieces in the chess, right? So they have said if the queen is here, then if your horse is here, then what are the possible ways to move forward, right? So like they have created rules. If this is here, that is there, then it has to move like that. Like that they have created, and it was able to defeat the world champion. So that was one of the earlier example. Now, so if you see this symbolic AI, what we are doing is we are basically giving the rules and we are giving the data. And what we are getting the answers. We are getting the price. Okay. But today in the machine learning, what we do, we have some data in an Excel format. Let's say we have millions of house prices and their features, and we dump that particular CSV or the Excel file into our machine learning to learn the pattern. So we are giving the data in the sense, what is the price of, what is the number of bedroom, the square footage, location, everything we are giving, and we are also feeding the price. What is the price of that particular house, which has 2 rooms, 100 square feet, and location is near to some 10 location, let's say. Then what it will do is it will create the rules by itself. It will say, okay, based on your data and your answers, I think the the price of a house varies linearly with the number of house. It will also increase linearly with the location score and things like that. It will create or generate those rules. Okay. And then if you ask, I have a room with these many bedrooms, square footage and location, then this system will tell you what should be the price of that particular house. Right. So there was a change in the entire, paradigm. Okay. Again, we saw what is artificial intelligence. We have seen the examples. And now within the artificial intelligence, we have something called the machine learning. Although we have talked a lot about this one, let's see how it practically works. Okay, so this is our training data, as I said. And those, the number of rooms and square footage and location, what are these called? They are called as the features. They are your independent variables. And the price of the house is what? Is our dependent variables. The value of the price will depend on these independent variables. Okay, and they are also called as the labels. Okay, so the data which we have for machine learning is basically a label data. Okay, so this is price of the first house. It has these attributes or the features. This is price of the second house, and these are the attributes. Okay, so what I will do is I will take this data and I will choose some algorithm. So there are a lot of algorithms. I will give this data to some algorithm, and we will, that will have some function inside it. We will train our model and it will learn how to predict the price of a house. Okay, so we train our models and it will create some generalized curves which will fit well into this training data. And if we give inferencing, means when we give input, we get the output, right? So that's what it is called, the prediction. So when we give some unlabeled data, for example, x3, x4, x5, then it will be able to tell us what should be the value of y. So this is called inferencing, unlabeled features. So it will give us the prediction basically. Any questions, guys? Am I going fast? Am I going slow? Am I deep diving more into the things which I should not? Your feedback is actually very important for me. Is it monotonous, boring, exciting? Feel free to
So
share. Yeah,
level data is the answer actually.
exactly. So we
Okay.
say 50 lakh is the price of a house, uh, for a house which has 3 rooms and it has 100 square feet area and the location score is 10. Another is 1 crore because the location score is 10. It is very nearby to hospitals and Delhi Metro and other transport systems, schools and social services, hospitals and all. And its square footage is 2000 square feet. And there are 4 rooms in it, 4 BHK, let's say. So its price will be high. So like that, we have data of various houses that we give to an algorithm. Algorithm is like, we have lots of algorithm based on what kind of problem we have. We have classification problems, or we have the regression problems, and then we have lot of algorithms. Okay, I will show you this on coding as well, how to code or how to train such models.
So inferencing, what is the inferencing then?
Inferencing is basically giving the input. For example, once this model is trained, what I will do is I would be interested to know the price of a house, right? For which I know the features. Okay. Now then I will only give these input features and it will be able to tell me, it will be able to predict the price of that particular house. If I say I have a house which is there in the New Delhi with 5 rooms and the square footage is 2500 square feet and location score is 8, then my system, my model will be able to tell me what should be the price of that particular house. That's what our aim is, right? We are creating a predicting model which can predict the house, the price of the house. So inferencing is the act of giving the input and getting the output. Okay, we will give input features and the models once trained will give me the output.
Okay, okay, got
In case of classification, let's think that, or maybe I have somewhere. Okay, so I will explain you this one also. So when we talk about the machine learning, we basically have supervised machine learning and another branch is unsupervised machine learning. So what is supervised machine learning? When we have the training data which has labels, right? As we saw in the last example, we have this label data. We know the price in at front. Okay, upfront we know the price of the house. That is called supervised machine learning. Okay, we already know the output or we have some sample data with the labeled data basically. That problem can again be of two types. One is a regression problem where my answer would be like, it can be any numeric value, right? For example, the price of the house can be anything, right? It can be 50 lakhs, it can be 50 crores, any numerical value, 50.26, 23.222, right? So it can take, your output can take any numerical value. Those are called as the regression models. Predict the number of ice creams. How many ice creams? That number can be 3, 4, 5, 6, anything. Sold based on day, season, and weather. There can be 1,000, it can be 5, it can be 6, it can be 100, anything. Whereas the classification problem, what we do is we basically classify. Okay. And we already know that we have the labels. For example, we have binary classification where we just have two different classes. Okay. Label is or is not. Okay. So whether a person is having cancer or it is not having the cancer. Okay. The image is a cat or not a cat. So we have just two categories. Your system, once you train, it will be able to tell you in the form of yes or no, which class does it belong to. Okay. Does that make sense? Whether it will rain or it will not rain. So that's a binary classification, just two possible results. There cannot be a third result out of it. Okay. There is a tumor or there is no tumor. He is suffering from COVID or not, COVID positive or COVID negative, like that. The other kind of problem is a multi-class, right? Where here we had just two classes, two possible outcomes, but in this case, the possible outcomes can be more than 2, 3, 4, multiple, more than two basically. For example, we have penguins, they have different features, right? Their height, their weight, their wings size and all. If you have all those input features, then you will see, okay, there are three possible categories of the penguins. And if you train your system with that data, and finally, if you bring some penguin and ask what is its species, then it will be able to tell you that out of these three, as per the features, your penguin belongs to first species or second species or third species, right? Or let's say if a given image, we want to say whether it's a cat, dog, or a mouse. We have three different classes. Is it making sense, guys? I mean, it
Yes.
may look a bit
Yes.
monotonous or maybe boring because this is, I mean, theoretical, right?
No, but this is very important because like regression, so these terms are will be utilized a lot later
Correct,
on.
correct. So this was all about the supervised machine learning. And second set of problem is unsupervised machine learning where the data is not labeled. Okay. So only I have is only the features I am having, right? So can you think of a problem where there are no feature, no outcome or no labels, but still we need to do some kind of machine learning and we have to find something. So there is one technique which is called as the clustering. There are couple more techniques, but I have listed just one. So what my machine learning system will do is it will say whether it's a flower of it will basically categorize my data into different classes. Okay, it will say that out of these 1,000 input images, these 200 images are very similar, so it will club all those images into one class. These two have similar features, so it will club into this into another class and this into the third class, right? So what it is doing is, so we at upfront we don't know how many classes it will create, but based on the similarity and dissimilarity between the features of the given data, it will create different classes of the flowers. For example, separate plants into groups based on the common characteristics. Let's say I have 10 different articles and I build a system. So what that system will do is it will segregate, okay, out of these 10 articles, these three are very similar because they are talking about sports. They are talking about, let's say, hockey, cricket, or something. So these articles are of sports in nature, sports articles. Other they will see, okay, they are talking about maybe Narendra Modi or maybe some chief minister or some international politics. And you will say out of 10, these three are politics related articles. Okay, so like that, what it can do is it can, based on the similarity between the different articles, it can segregate them into different groups. Okay, so those groups can be two, maybe three, or maybe four. We don't know, right? Does that make sense? This is basically called as
Yeah.
the unsupervised machine learning.
So how it do the grouping? Is it
So
using the supervised learning multiple
no.
classification?
So it will do the grouping based on the similarity, right? So it has some algorithms which by which it will see whether the shape of this leaf is similar to the leaf size of the another flower, then it will club them. The leaf of this, the let's say the number of leaves are three petals or sepals, whatever they are. They are three and three. So what they have done, they have clubbed them into one group. They have more number of sepals, one, two, three, four, five, six, seven, eight. All the other flowers which are having eight sepals, they will be clubbed together into one group, right? So these two classes of flowers are very different because they have different characteristics. Those characteristics are the features basically. Whatever input features we have, based on that, it will calculate the distance between those, right? Are you getting?
So example means I'm just thinking of an
Mm-hmm.
example
Mm-hmm.
like classification of services.
Mm-hmm.
Let's say we have different services, repairing a wall, right?
Mm-hmm. Right.
Repairing a tap,
Mm-hmm.
and then changing the electricity wire, changing the
Correct.
bulb,
Mm-hmm.
repairing a fan, changing the
Mm-hmm.
motor of the fan,
Mm-hmm.
right? Repairing floor of the house.
Mm-hmm.
So these services are there. So right now there are no labels, and if we want to group them or put them in plumbing, masonry, or carpentry, or these kind of service classes,
Mm-hmm.
then probably we can relate them. Is it related to
Exactly. Exactly.
electrical,
Exactly.
something like that?
Exactly. So whatever input features we have, as I said, what are input features? Input features are basically these features, right? X1, X2, and X3. So in case of unsupervised learning, also we will get this type of CSV or Excel sheet, but there will not be an output, right? It will just have features. For example, as you said, let's say we have some parts of some company, Walmart, let's say. So Walmart is having this part as part number one, which is having features like it has some wattage, it has some power input, it has some output. Okay, those are the features. The other, let's say there are some plumbing things where we talk about toilets, pipes, the diameter, and things like that. So what it will do is, based on these features, it will try to group those parts which are similar in nature,
And get the
right?
labels.
Yeah, I mean, if you have the electricals things, they will definitely have, right, what is the input voltage, what is voltage, what is wattage, what is power rating, and things like that. So all those parts which are having such similar things, they will be grouped together. Just give me a second, guys. Just a second. Guys, let's take a 5 minutes break. My kid needs some attention. Okay. Sorry for it, guys.
ठीक है. Okay.
Okay.
Like, is anybody here from US time zone?
No, India.
Everyone
I'm
is
in
from
Gurgaon.
okay.
Maybe we can
I'm in
introduce.
EST time zone, but not in US, Canada.
Okay. Yeah, maybe we can take a one round of introduction. We should ask Surendra, but we can utilize these 5 minutes quickly.
Yeah, yeah, yeah. Okay, so maybe with name I could start. I could see. Okay, so myself, Amit, I am working in Ericsson, put up in Gurgaon, and basically I am from MBM Jodhpur College, so that's why I know Surendra also. He is from the same college. That's it, and I'm in telecom. Yeah, not much in core telecom. Working in core telecom as a senior manager. So not much in AI or ML, but yes, definitely it's a lot. It's very much required. So that's the objective.
I can go next. So I'm in US. I'm working for Walmart, and I'm a senior engineering manager. And I know Surendra from Buildersoft. So yeah, I mean the objective to learn this because AI is a new buzzword everyone needs to know, and like Walmart also expecting even director and senior managers to start using the GenAI tools and do a little bit coding, put the hands on. Yeah.
Tarun, right?
Yeah.
Okay. Yeah, Tarun, I suppose GenAI is what is being pushed inside organization if I see
Yes.
internally. Yeah.
Yeah, now it's Anup Kishore this side. So currently I am working as a developer, Java developer. So we work for the bank application, and currently I'm working in the Rolla Soft. So as a part of transition or some uh, extra knowledge, I am just doing this course. So that's all.
Good to know.
So Anup is having proper background, huh? He's
Yeah.
from development.
Yes.
Yeah, myself Chaitanya, and I'm working as a data engineer. So in all the ETL stuff I'm working on, like regarding using the Databricks and all. So maybe I'm trying to learn the AI so that I can leverage more into my project and then make use of AI and then Gen AI as well.
Okay, so you are in database, Chaitanya. Where?
Yeah,
Which
I mean,
company?
in Infosys,
Okay, Infosys.
yeah, mostly into PySpark, Databricks, and Python. And, yeah,
Okay, so you
Spark.
are also.
Yeah,
for the
but I'm
software
not into the
background.
AI. Yeah, not into the AI side. Yeah, need to see how much I can able to.
Hey, hi all. This is Akash. I am working in Cognizant and currently a technical manager. I worked into a product suite called Documentum. It's a content management COTS product, and I mean I have been leading the team. Okay, currently though I'm not into much technicals, but yeah, Documentum. I mean, since this is based on content management, probably AI. I want to learn AI to leverage the Documentum's or content management features currently.
Hi,
Everyone.
myself
My name is
Sridhar.
Raghavendra. I'm the working as a technical manager in OpenText, uh, and I'm supporting Ericsson client there. And as Akash working with Documentum, right? The same tool I'm also working over there. Thank you.
Yeah, myself Sridhar. Same like Raghavendra and Akash. Mine also Documenta experience. Recently, I moved to AI and AWS. I have POC kind of experience in AI, like AWS, Bedrock, SageMaker. Currently, I'm in Canada.
Who is left? Nitesh, Vikas.
And
Hi,
left.
myself Nitesh. I'm working in Optum, a healthcare company, US. Currently in Gurgaon, and I'm working as a solution architect in RPA, robotics process automation, and overall automation and transformation for operations.
Which company, Nitesh?
Optum, UHG, United Health Group.
Okay, Optum.
Hello, good morning. Vikas here. So I belong to telecom domain only. So I'm working in the R&D part of 4G and 5G development as a tester. I'm in the part of the Land Zero company. Okay. So I'm already learning this one. I think I'm pursuing in the higher study also. So I'm pursuing this one like deep learning, ML, everything. Already I'm going in my the line. So just I'm not sure how we are going to implement this course in the telecom domain. So I'm trying to explore that part.
Use case, right,
Correct. Use case.
Vikas?
Yeah, we are not able. We don't have it any. I think maybe I didn't find out, but I'm not able to find the use case how we are going to implement this.
Yeah, you are in Geo. Which
Part of the
place?
Redis company,
Okay, which
mm,
place?
Bangalore.
Bangalore. Okay, okay.
Hi, good morning, everyone. My name is Nitin, and I'm also working in a telecom company in a QA domain. So there, we are means exploring the more and more options how to use all these tools to build the software better. Actually,
Okay, Nitin. Three telecom, Vikas, Nitin, myself also.
Okay, hi everyone. This is Saurabh. I'm also part of an Optum, which is a USG-based company. And I have experience in automations and this, I think, GenAI and the artificial intelligence and AI I think, what we are planning to implement in most of our automation now. So I'm at the learning phase. At this point, right? I'm based out of Noida.
Okay. Who is left?
Hey, hi everyone. My name is Karthik. So currently, I'm working in a retail domain in TCS. So working as a delivery lead and technical lead for a couple of projects. So I'm here to learn more about AI and ML, which we are trying to implement in our projects. So I have experience predominantly on the database side. So I felt like it'll be a good start for me to start here.
Hey, hi, this is Rameshwar.
So I'm part of Asian Labs, and I'm working as a site reliability engineer in Paracode. So moreover, I have AWS side and security side. I have the knowledge. I need to elaborate this AI. So to do that, I'm in the AI call. That's all from my side.
Hello everyone, this is Vikas Mishra. So I am in Documentum and XCCM architect at OpenText and having around 12 years of experience in IT industry. So right now, nowadays company is opting this AI in machine learning. So and this is going to become a part of interview, even if you are going for any skill set. So now the company has already introduced that if you don't have AI skills, then you will not be shortlisted for interview. Even OpenText has did that. So that's why I started learning the GenAI, and I have opted for this course. Thank you.
All right, everyone, I'm back. I was hearing the introductions for at least last 3 to 5 guys. I mean, that's really good.
Yeah.
We were trying to utilize the time, Suren.
Yeah, superb, superb.
So we can have supervised ML in the introduction also. Same companies, domain, telecom domain.
Yeah, yeah. I mean,
We can label.
exactly. So this group is not only for, learning these things. We can collaborate with each other. We can share, where do we work, whatever our experience is. So we can utilize this as a platform, right? We can use it as a community to help each other as well. All
Lastly,
right.
Surendra, would you
Hmm.
like to introduce yourself, your
Oh,
experience as well?
yeah, sure, sure. So I have total 18 years of experience, guys. So I started my career in 2006 with the TCS. So I worked there for 3 years, and I was working in the ECM, Enterprise Content Management, right? So you must have heard, right? Some of you are actually working in the Documentum. So similar to the Documentum, there is a product from IBM which is called FileNet. So I worked in the FileNet for initial 5, 6 years. Then I switched to the Documentum as well. So I worked for 2 years there. And then, so from TCS, I went to the Birlasoft. There I spent a lot of time, more than 10 years. And right now I am working with the Genpact. So here I am working as a senior principal consultant who is working in the generative AI. I have delivered, 5+ projects in the generative AI. So yeah, that's pretty much. Okay. So I would not like to talk much about Genpact and my current projects because of obvious reasons. Okay. So, but yes, I can use that knowledge or whatever I have learned in the past 5 to 6 years, especially in this area, in this domain of AI ML, and I can share my knowledge with you guys. Okay.
Yeah.
All right, then let's go back to our deck. So I hope this is clear to everyone. What is machine learning? Okay. If you're not able to complete this deck today, the session one agenda, I mean, that's fine. We can use the second session. So the only thing is, I want you to understand these things. Okay. And that may take some time. That may take some time to digest all these things. If you are hearing it for the first time, it will definitely take some time for you to digest all these things. So take your time. There is no hurry. We can have more sessions if you want. If you're not able to understand anything, you can let me know. We can have doubt sessions as well. So I will try my best to explain whatever I know, right? And you should also do the work at your end. In order to learn, you need to do some hands-on, you need to practice, maybe you need to go to the YouTube again to see, to deep dive into certain things which you're interested in, right? Because we cannot cover each and everything in this course, right? In the next 14, 15 weeks. For example, machine learning itself is a subject, right? It may take, some 6 months to learn machine learning. There are different algorithms, where to use which algorithm, how to evaluate a machine learning output, what is confusion matrix, right? All those things, false positive, false negative. There are a lot of things, right? So even this subject will take 6 months. Similarly, the neural networks, right? So that is again a different paradigm where it will take at least 6 to 12 months to understand. That is more complicated, right? But in this course, I will just give you the very high level overview, and I will also try to run something in front of you so that you get, most out of it. Okay, so far you have only heard about machine learning and you know the concept, but when you look at the model running, then you will realize, okay, this is not that hard. Only thing we need to do is we need to use some Python libraries and we are all good to go. Okay, so that I will show you maybe in the next lecture. I will run some models. Okay.
So, Surinder,
Will this
Hmm.
be shared, this slide or this recording?
Slides, this recording will be shared. Okay.
Uh-huh.
Slide, actually, I have taken the content from here and there, right? Maybe something from this website, some other that may have some copyrights.
Okay,
So
okay,
I'm a bit hesitant on sharing the slide, but yes, videos will be shared with you guys.
okay.
Okay.
And maybe some other links you have,
Yeah,
those are not.
yes,
Huh. Correct.
definitely. References I will share where you can, read more about these things.
And just one more thing, can we plan this in the evening for the like 8, maybe because this morning weekends, right? If they required something related to
Hmm.
with the kids actually go outside.
Yeah, yeah,
Maybe
I
if
understand
everyone is
that.
agree, then it's fine. Otherwise,
Hmm.
we can't do it.
Correct, correct. So, I mean, I actually asked what is the timing which suits most of us, and this is the slot where I got the maximum votes, because there are a couple of people from the US as well. So I just want to cover them also. So Saturday evening is again very tough for a lot of people because they want to go, some outside. They want to do outing in the evenings. So I think it's better to choose the morning slot. Most of the kids usually sleep at that time, so I wanted to finish it off maybe in the morning so that you can have the entire day for yourself. That's the idea basically. Otherwise, you will always have in the mind, in the evening I have a call at 8 p.m. or 7 p.m.
True, true, true.
So I mean that's my thinking, but if everyone agrees for some other slot, I'm okay.
so it's once in a week or twice in a
It's once in a
classes?
week. If you have doubts, we can connect twice as well.
Morning is the best.
Yeah. Yeah, morning is.
Yeah, morning. I mean, we'll get our time. We can
Yeah,
share with our family. So morning is always
exactly.
better. It takes a while, 1 or 2 weeks when we start,
Correct,
but
correct.
yeah, we'll get settled with it.
Yeah. Anyway, you have the recordings. Just in case you are not able to make it, you can go through the recording video and then you are good. Okay. So we have seen the different type of machine learning, supervised and unsupervised, and then regression, classification, and clustering, and then model training and evaluation. Okay, so whenever we train any model, we have to evaluate, right, whether it has been trained correctly or not. What is the accuracy? Is it 80% correct, or it's 70%, or it's like 95%, right? So those things we need to do with the help of evaluating parameters. So there are parameters with the help of which, as I said, there is something called the confusion matrix, with the help of which you can evaluate whether your model is properly trained or not. It is able to predict the things right or not. Okay, so usually whatever training data we have, we divide it into two parts. One is the training, other is the validation data. So we train the model on this part of data. Let's say it is 70% of the total data. We train our model on this one, and then we use this one to predict. Okay, we will not use these Y's, although we already know the result, but still we will, in order to test our model whether it is giving right predictions or not, I will split it into two parts and I will use this validation data to validate my model. Okay, so I will give these x1, x2, x3, these input features, and I will try to find the y value. And then I will compare how many y's I was able to correctly predict. Is it clear, guys? This is important. So I will split my data, input data. Let's say I have 100 rows of data, 100 data of my pricing, problem. For 80 houses, I have used the data for the 80 houses to train my model to learn the pattern within these data. My model has been trained and it is learned patterns from these data. Now, how would I know whether my model is correctly trained or not? Because there are a lot of problems in the training as well. Okay, we will not go into that. There is something called as the what do you call overfitting, underfitting, and things like that. So with those 80 data points, I will train my model, and in order to predict the performance, how my model is able to predict whether it's right or wrong, I will use the 20 data points to judge, and I will calculate the y, which y the predicted one, and that result I will compare with the actual result. Right, and then I will see, okay, out of 3 it is able to predict only 2, or maybe it's not able to predict any of these correctly, and that with the help of that prediction we calculate some matrices basically, which help us to judge whether our model is right or wrong, how accurate it is. Is that clear? आया समझ में नहीं आया?
Yeah, this one is
Yes,
Yeah,
Okay,
should be good.
great,
Yes.
great. Okay, so deep learning, as I
So,
said,
I,
yeah.
I just have one question.
Mm-hmm.
So related to this models, right? So when you said we have to, when we do this kind of predictive analysis and all those things, so we train it with certain parameters. Like say, suppose we create a model and we train it with 10 different parameters. Now, if there is any new parameter which comes into the picture after, say, suppose after we analyze the data that there is a new parameter. So do we need to train that model again, or
Yes, you
how?
have to, right? If you want to consider that, let's say in our housing problem, there is some another
Mhm,
factor which says whether there is a water supply in that area or not. If that's a new
mhm.
feature, and if that feature is basically deciding the price of the house, then if you want to consider that as well, then you need to retrain your model with
Okay,
including
so we
that
have to
feature as
retrain the
well.
word.
Exactly.
Okay, so we have to retrain it again from the means
Again, from
with that
scratch.
parameter. Yeah.
Correct.
Okay.
All right. So deep learning. So we have learned what is AI, what is machine learning, and deep learning. As I said, it's basically inspired from the human neural network. There is something called the artificial neural network. Okay, neurons fire in response to electrochemical stimuli. When fired, the signal is passed to the connected neurons from one neuron to other, from other to this. Maybe at some point of time, this is not activated, right? Only these are activated. For some other response, maybe all are activated, right? So similarly, what we do is we basically create we create different layers, and each layer does have some neurons. Okay, and within the each neuron, what happens? Some mathematical operations basically happens. Each neuron is a function that operates on an input value x and weight y, right? So we basically, when we start training our model, we randomly initialize these weights. So end of the day, what we are doing, guys, we are actually calculating those weights, right? The value of those weights, these weights, W1, W2, and W3. If I know the value of these weights, then what will happen? If I give value for any like number of bedrooms or square footage or location, I will get the value of my price. Yes or no? Right? In order to predict the price, I should know the value of these weights correctly. The more accurate these weights are, more accurate my price will be. That's the only end goal we have. It's like the old transistors where we have those round knobs, right? So what we do, we may move some knobs clockwise, the other knobs anti-clockwise, and we have to find a position where it will catch the network. Are you getting? So those anti-clockwise and clockwise and setting those knobs is similar to finding the right value of these weights, which are associated with each and every neuron. Once I know, that's why we do the training. We give it so many data that basically will help us to calculate the right value of those weights. Once I get those weights value, then then our system is ready. It will be able to predict it correctly. Okay, so each neuron is a function that operates on an input value X. These are my input features and weight W. Initially they are randomly initialized. I give any value to weights 0 0.6, 0 0.5, 0 0.2, something like that. And then I will train my model. Okay, the function is wrapped. I will explain this further. The function is wrapped in an activation function. Activation function that determines whether to pass the output on. Okay, so there are some activation functions like ReLU function. Okay, so you just think it of some mathematical functions like sine x, cos x, log x, or something. So we choose some function, and within that function we pass those x and y values, getting the input feature and our weights, and that mathematical operation will take place in the neuron, and output will be given to the next neuron. In the next neurons also the same thing will happen. It will have its own weights, and the value of x has get changed. Whatever value we will get, that will become my x, and then further I will do the same operation, and so on and so forth. Maybe another diagram will help us to explain this work. Okay, so this is another example. So this is the penguin example, where based on the length, height, weight, or the size of the beak and all those things, I will try to classify what species this penguin belongs to. Let's say there are three species of the penguin, three classes. So first of all, you can see the output is in the classes format. So what type of machine learning problem it is? Is it regression or classification?
Classification.
Classification. It's a
It's
binary or the multi?
multi-class class.
Multi-class.
It's a
Multi.
multi. It's a supervised or unsupervised?
Unsupervised. Sorry. Here, what it is.
Supervised.
It's
Supervised.
supervised, right? Supervised because I have number of classes, and when I'm giving my input data, I'm also telling for x1 value this one, this two, this is a species 0. For these input features, the species is 2, or the species is 1, 0, 1, 2. So I'm not clustering basically. Okay, so this is my input data will have both the things, input features and labels also. Okay, if the length of the or the height of this penguin is 10 centimeter, then it's basically a class 0. With the 12 centimeter, the class is 1. With the 15 centimeter, the class is 2. Like that, I have my input data. Okay, but my output is only out of these. That's why it's a classification problem. It's a supervised problem. It's a multi-class classification problem. Okay. So now these are my input features. For each penguin, I have these features x1, x2, x3, x4. Okay, this is like my housing problem. It will become carpet area, maybe the number of bedrooms, the location score, and some other score. For the penguin, it will become x1, some length of the hand, limbs, or foot, or whatever. Okay. And these input will be given to my input layer. So this is called as the input layer, and this is called as the output layer. And all the layers which are in between input and output layers, they are called hidden layers. Okay. So once these input x1, x2, x3 for the first records are given, it will do some mathematical operation, and then it will go to my second layer, my first hidden layer and second layer in overall. And there will be some weights W1, 2, W1, 1, 1, 2, W1, sorry, W11, because it is going from first. We have some set nomenclature. So this is our layer 1. So this it will be 1 W1, and it is going to the first or the second layer. So W11, W12, W13, W14, like that. These are the weights. Those weights will again be multiplied, will be given as an input, and some mathematical calculation will happen, and then it will generate some new value, which is again given to other neurons. Like that, it is passed, and then after traversing through the network, what it will do is it will calculate this y1, y2, and y3. So what will happen? There will be a score of these three classes. For example, what is the probability of having this penguin? When I am testing this, what it will do is it will say, let's say I have given some data of some penguin for which I want to know the class, right? Whether it's class 0, 1, or 2. So what my neural network will do is it will, once we give the input, it will tell me the probability of having this penguin as a species 0 is 0.2. Okay, that means only 0.2 features are actually matching with the class 0. 0.7 is the probability that it belongs to the class 1, and 0.1 is the probability it is belonging to the class 2. And then what I will do is, okay, so this is the maximum. I will say this basically penguin belongs to the class 1. So this is how it happens basically. It calculates the probability score for all the classes, and for the class where it is maximum, it will say, okay, this is the maximum. This species belongs to class 1. So we calculate the probabilities basically, and the sum of these will be 1, obviously. Okay.
So here activation function is probability.
No, activation functions are basically will do the probability will you will get in the last. The output of these neurons will be like y1, y2, and y3.
Okay, so it will be the hidden layer
Yeah,
which will
where the
get the
activation functions will be there, some calculation will happen, and then it will pass the value to the next layer. Okay, so it's a bit complicated. Maybe in the next class when I show you the code, then it will make it will become easier to understand. Okay, so that's how the neural networks work. So I mean, in this slide, I just wanted to show you, why there is a sudden boom in this generative AI in the last 2-3 years. What actually happened in the last 4-5 years that out of sudden why this is a buzzword and why everyone is running behind this technology. Anyone has any clue why this happened now, not in 2010 or not in 2000? Why suddenly in 2020s we are hearing more about this particular generative AI? What
More
has
data is getting generated.
exactly? That's one of the reason.
I think computing cost also goes down. That
Correct.
is one of
Computing cost and as well as the availability of these,
availability. Yeah.
right? So if I need to
GP,
train some
CPU.
model, yeah, if I need to train some model, and let's say I'm even not a company, right? I'm just an individual person. I want to train some model, right? So earlier there was no mechanism, right? How I can buy those very heavy computers which are having huge compute powers and all those things. Now with the help of these platforms, these cloud platforms, it's very easy, right? I can just spend a couple of dollars and I will be able to train my model. So the availability of compute is now very easy. The amount of data which has been generated is now has increased manifold. In the last couple of years, the amount of data which we are generating is huge and huge. Every second there is a petabytes of data which get generated, knowingly or unknowingly, right? Right now we are having this class, the data is getting generated, correct? So there's a lot of data which has been generated. There are platforms which can provide us that capability to do some computations, right? Run our machine learning models and machine learning innovation also, right? Machine learning innovations in the science, there are some algorithms now. For example, there is something called the transformers architecture. So transformers architecture was basically a research paper which was released by Google in 2017. That changed the entire game basically. These models which even you see today in 2025, they are also based on that transformers architecture. Okay, so that release of that architecture was one of the biggest event in the history. We will talk about that, but these are some of the reasons why out of sudden we are seeing such a boom in this area. Okay, so again, if you remember that circle, there was an AI, there was machine learning, and then we talked about artificial neural networks. If you have more number of layers, it is called deep learning. And now the question is, what is generative artificial intelligence? Creates new content and ideas, including conversations, stories, images, videos, and music, right? So this is a bit different from the earlier things, right? Now we can create some images which you have never seen, as I said, right? This is a dog with a hat and the spectacles, this butterfly. So all these images are actually the model has never seen these images in past, right? But still it can generate some content which is new. Today, if you want to, you know, if I want some cover page or some thumbnail for my YouTube video, I need not to spend a lot of hours to generate. I can simply write a prompt that this is what I'm going to create, generate a thumbnail. So it will create some image which is relevant to for your video, right? So this is not only image, it also includes text, audio, video, everything. Okay, powered by large models that are pre-trained on vast corpus of data and commonly referred to as foundation models. So here I tried to explain you what are traditional machine learning models and what are foundation models. So earlier what we used to do is, if I need to process some text, then I will use traditional machine learning models. I will train them and they will be able to do some task. Okay. For example, let's say I want to do some sentiment analysis of reviews which are there on my Amazon product. Got it? I have my product listed on Amazon and people has given its feedback. So let's say there are 100 different comments which are there for my product. Now I want to see whether what they are trying to say, whether those feedbacks are positive or negative. Then what I need to do, I need to analyze those 1,000 comments basically, right? So I can train my model. I will give lot of comments. I will say for the comment one, the sentiment is positive. The user is very happy with my product. Okay. It will write something like, I'm glad to use this product as such a price. Okay. All those things. So what I will do is I will create some data set where I will have the sentiment, the user comment and its sentiment, whether it's positive or negative. Next, maybe the worst product I have ever used. Next, feedback from the user can be worst product I have ever used. So that the sentiment of the user is what? Positive or negative? It's negative. So I will say it's negative. So like that, I will create one data set with those 1,000 reviews from the users and whether those sentiments was positive or negative. I have to mark it down myself. Okay. I have to, someone has to sit and say whether that review was positive or negative. Once my that data is prepared, I can train some machine learning model which will do what? Which it will see what is the pattern in the reviews. Whenever we are using the word, it's awesome, it's super cool product, I'm very excited, I'm very happy. So machine learning models will pick these words and it will decide, okay, whenever in the feedback I have these words, that means the user is happy. That means the sentiment is what? Positive. So I have trained that model and now I can use that model to predict whether the users are happy or not. Is it clear, guys? I'm not using any diagrams or something. I'm not sure whether you are able to understand. समझ में आया सबको?
Yeah.
Yeah. So nowadays, even on Amazon, we see, I mean, that what do you say, machine-driven review
Exactly.
also generated.
Exactly.
Yeah.
So it will talk about what most people are talking about, with which features most of the people are most excited. Maybe it's temperature, maybe it's voice quality, or maybe something else, right? So that basically do some machine learning on the comments and it will give you some insights. If people talk most about its durability or its flexibility or whatever. So they are only because of some machine learning models which are running behind the scene. So yahan par what I'm trying to explain you is earlier, in order to do one task, which is like sentiment analysis, I was collecting the data, I was labeling the data, I was training my model, and then I was using that model to interpret some reviews which the user will give in the coming days. Yes or no? Right?
Yeah.
Similarly, if I want to do something like summarization, I have a one page and I want to summarize it. Similarly, I will train another model. I will say, okay, Mr. Raji, you sit with 10 people, you make some model, this is the data, and you create some summarization application or train some model which can do summarization. Then that team will do that thing. Let's say you have to do some information extraction. Again, so what I mean to say is, earlier days, in order to accomplish different tasks, we used to train different models. We should have bandwidth and we should have resources to do all these tasks separately. 10 people are working on this application, 10 are training this model, 10 are, so there are 50 people are needed to build these 5 models. Now what is happening is, now we have something called as the foundation model. For example, we have OpenAI's model, GPT-4o, let's say. So what OpenAI has done is, they have trained their model in such a way, they have taken data from all over the internet and they have trained their model using, so they are based on transformers architecture, which was, some major breakthrough in the history. They have used that transformer architecture and they have trained their model with lot of data which is lying on the internet. Obviously, it's not very easy. They have to scrape the data, they have to clean the data, and only if they are able to download 100 GB of data, maybe they are just using 2 GB of clean data to train their models, right? Because training the model is not that super easy. You have to see your data is biased or not. There are a lot of other considerations. If your data is bad, your model will be trained badly and it will give you some absurd results. Correct? So you have to be very careful that with whatever information you are training your model, that should be unbiased and that should be clean and all those stuffs. But my point is, if you have done that one time, if you have trained your model in such a way with a lot of data, maybe you will take some code from the GitHub and you have trained your model. Now your model is able to code itself because it has seen a lot of patterns. It has gone through a lot of coding problems or codes, that now it has become proficient in writing the code. Let's say we have some hospital data or some finance data, some banking data. So we train our model in such a way that now it is able to understand how the bank works, what are the different regulations and all those things. End of the day, once I train my model, large language model, my foundation model, what it will be able to do is, now it can do all these things like text generation, summarization, information extraction, question answering, and chatbot. With just one model, now I can do all of my tasks. Earlier, what I was doing is, I was training each of these models separately. Okay, my text generation model cannot do summarization earlier, and my summarization model cannot do text generation. So each model needed a separate team to train the data, to collect the data, to label the data. Now everything is being done by some third party, that is called Google. Google is, let's say, creating Gemini models. Okay, OpenAI, they are giving their GPT models. Meta is giving their Llama models, right? So now these companies having huge capacity, they have huge compute power, they have access to the data. That's why they are king now. They have created such models which are trained on vast amount of data, and those models, for example, our chat GPT can do text generation. If I say write one essay on Narendra Modi, it will be able to write. If I say these are 5 pages, summarize this in 5 lines, it is able to do. Yes or no? It can do summarization.
Yes.
If you say from this article extract the name of all the places, it will give you the list. In this article, there are 10 places, 10 hotels name. Okay. If you do question answering, you can do question answering, right? You can talk to it like a human being. Hi, how are you? Can you solve this? Can you tell me that? And it's also a chatbot. So now you can see the difference between these two. So that's why there is a huge change in the way we actually have been working. Everything has been changed because of these foundation models. They are capable of doing multiple tasks. Now all you need to do is, you need to tune these foundation models, or you have to create that interface as per your requirements. Okay, so this we will learn. They also expose their APIs. So we will use those APIs and we will give some input prompts to these foundation models and we will get some output. And then it's up to us how to show on the user interface and on the web applications and things like that, whether to retain the conversation or not, all those things. Okay. Now you can see, now I need just one team, right, which can just write my application. I just need software developers. I don't want to train my models. I don't want to get mess with the data, labeling the data, cleaning the data. All I need to do is I need to use pre-trained models. That's it. Everything has been done. That's why they are charging, right? For each token, they are charging. They are earning huge. OpenAIs and Googles and all these things. I hope this has given some intuition to you guys.
Yes. And can we categorize this one in supervised and unsupervised also, like the right one unsupervised, or that is for ML?
That's for ML actually. So for
Okay.
this, they are actually trained with both mechanism. These models are also trained, right, with the huge. So that's a combination of supervised and unsupervised. That's a very complicated way how they are trained. We will talk about it little, but they are combination of both supervised and unsupervised. Okay.
ठीक है.
But end of the day, we have some model which can understand our language, our natural language. That's the best thing. I say, create my resume. I worked so and so. It will create my resume. I say, create a learning plan. I want to take GenAI classes. Make a plan for 12 weeks and list the topics. It will list all the topics, right? Because it is able to understand my language. This language understanding is the key milestone which we have achieved, right? Because human language is very, very tough, right? We use couple of times some slang words, and every people talk in some different way, but still these systems are able to understand that. That's the beauty. Each word is having multiple meanings, yes or no? But still the bank is a bank also. There is a humor bank station also. The river bank is also there, right? But still it will able to understand what bank we are talking about based on our sentence, on our context. Earlier these language problems were very, very, the people had very tough time training these models on the language, because language has different meaning in the different context. Now with these models, everything has been sorted out. Most of the things, the models still hallucinate, but that's what we will learn, how to make it, how to control that hallucination, and how to make proper use of these models. That's the main idea of this particular course. Okay. All right, so we talked about inference little bit. So inference is what? We have some models that can be a machine learning model, or that can be a language models. We give some input and we get some output. Okay. The prices of house, the features of the house is my input, and the price of the house is my output. So that is also called inferencing. Inferencing a model means basically in simple terms calling a model. If I call a model, I will give some input and it will give me some output. In case of language models, our input is called prompt, and language model returning the response for my prompt is called completion. Okay. So that's why there is a name of the API called completion API. And this whole process is called inference. Prompt input text to the model, completion output text generated by the model. Inference is the process of generating a completion from a prompt using a large language model. But this term is also applicable for traditional machine learning models as well. Okay. Then transformers model, that is something, the revolutionary thing which happened in the history. And Google researchers basically released one research paper about the transformers. So if you are interested, you can go ahead and just type on the Google Chrome right now. Attention is all you need. Research paper, then it will show you the very first link from Vaswani. So what they have done is they basically designed this architecture. This architecture is although very complicated, but in short, I will try to explain. So there are two parts of it basically, right? The left hand side part is called encoder. The right hand side part is called decoder. What this encoder will do is, encoder will try to understand my input sentences. Okay. Convert input sequence to hidden states, takes input text and creates a numerical representation of the text, positioning it in a semantic field. So let's say my sentence is, why did the chicken cross the? Okay. So if that is my input, this sentence is my input, there is something called as the input embeddings. So my model cannot understand these English words for sure. right? So I need to convert them into some mathematical representation. So I will use some embedding model to convert this word y into some mathematical function or a vector. Okay, so this is called input embedding. I'm embedding or using some API to convert this word into some mathematical representation. Cool. So I have 6 words, I will have 6 embeddings, 6 mathematical representations. Now there is something called as the positional encoding. This will basically help us to tell the system that y is at the first place, did is at the second place, so that because in language the sequence is very important. Correct? If I change the sequence of words, the meaning of entire sentence will change, right? So I have to maintain the sequence of these sentences as well. So that's where I use positional encoding. And then this sentence will be given to my encoder part, where what I will do is I will try to find out the underlying meaning of this sentence, that what user is trying to say or what this sentence means basically. So there is something called as the attention mechanism. Okay, so it will pay attention to the most important words in this sentence. Okay, for example, the attention weightage given to chicken maybe 0.7, cross is maybe 0.6, the is maybe 0.2. So attention means giving more attention to the most important part or word of the sentence. So it will do some operation, it will try to find out the underlying meaning of this sentence, and then it will give it to the decoder part. So decoder part will do what? This transformer architecture does what? They try to predict the next word. Okay. For us, I mean, when we see the chat GPT, it generates lot of responses and we are amused, how it is able to generate. But all it is doing is it is just trying to predict the next word. So when I write this word, why did the chicken cross the, it will only based on these words and their meaning and their attention, it will only be able to find what should be the most probable word after this sentence, that is a road basically. Okay, there can be some other words also, but the probability of road is the maximum. That's why it will say, it will produce the output, why did the chicken cross the road? Maybe the road is having 0.8 probability, maybe the river is having 0.1. Okay, so the word which is having the maximum probability will be given as an output. Like that, what will happen after the road? It will give the road as an input and it will try to find the next most probable word after the road, and so on and so forth. That's why if you see, your answer is always generated in tokens word by word. Yes or no? When you use chat GPT, if you ask anything, the words are printed one by one. It's not like that in a fraction of second, it will give you the entire 100 words or 200 words response, right? So that is because it is called streaming basically. Streaming means as soon as the language model is generating the tokens one by one, it will calculate, it will predict the next word road, and then maybe full stop, then maybe the first word of the next sentence, and the next word, next. So it basically generates the tokens. These words are loosely, you can say they are tokens basically. Okay, so there is a difference between token and input, these words, which I will explain. But for the time being, just understand that these individual words are basically tokens for this system. So what it is doing is it is just generating next token. Even if it is end of the day, it is giving some 200-page answer, but all it's doing is it's trying to find out the most best suited word after the last word based on all these words. Okay, so this is how it will do basically. It will give all these words and it will say, when it's generate road, it will give road as an input. Then it will say what is the next probable word after the road. Then that will given as an input and another word. So like that, it goes on. Okay, so this is a very high level overview of how this architecture works, right?
So
Yeah,
it's a transformers model. No?
yeah, it's Transformers architecture, which was released by Google researchers. So there were earlier models which were tried and tested by many researchers, but they were not successful. If you see some neural network guides, there is something called as NLU, There is something called LSTM. So all those models basically tried to solve these language problems, but somehow they had one or some other problems with them. They were not, if you give them this 5 or 6 lines, so by the time they reach here to understand these words, they will forget what is meaning of encoder or convert or something like that. So they had lot of demerits basically. It was not able to process large data. But with this transformer architecture, all those problems were sorted out. And we have a system which can generate, which can retain the context. The main thing is context of your text, what you are trying to say. Okay. So in order to understand that, you need to consider all the words and you have to remember their attention basically. What is their meaning? Then only you will be able to understand what the user is trying to ask. Okay. This is a very, very high level overview from helicopter view basically for you guys. Okay, if you're more interested, I can explain you this, or maybe you can just type attention is all you need on your browser. You will get one research paper. Okay, but this was one of the most revolutionary thing in the history. Although Google invented or Google released this paper, but somehow you have seen, right? OpenAI basically uh, is winning the race. They have generated these GPT models, right? They are leading the race basically. But it was Google who released this architecture. So what is LLM? LLMs are trained on large. So even in the name you can see, right, large language model. So these are basically large models. So how do you define whether a model is a large or a small model? Anyone? Any guesses?
Trained on large data.
Yeah, right. So what happens is, as I said, right, earlier, our main motive in training any model is to find the right value of the weights. W1, W2, W3. If I have correct value of those weights, my price of the house will be more accurate, isn't it? So when I say large language models, then the number of those weights, first of all, you should understand the more the weights, the more memory I will have, the more patterns I will be able to understand or store. Yes or no? If I have 1,000 weights in one model and the other model is having 1 million weights, which is more efficient or which can understand the more complex patterns, the larger one, right? So that's what, when we talk about large language models, they have number of weights in millions. 40 million model, 40 million parameters. So what is that million? That is number of parameters it is having, number of weights it is having, for which we do the training. End of the training, we are setting, okay, these are the right value of these 14 million weights. Now you can understand how difficult it is to train the model and to find the right value of those weights basically. Okay. So they are so large that, then you need so much of compute power, so much of electricity is needed, right? That's why you have heard, right, OpenAI and these companies are actually acquiring nuclear power plants in order to fuel or in order to run their models, because you need lot of electricity. That electricity is equivalent to the requirement of a city for the 6 months. It can fulfill the needs of a small city for the 6 months. That much amount of power is required to train these models. So that's why they are acquiring their own nuclear power plants.
So why electricity is required?
Electricity is required because you have these million parameters, right? You need to store these. Actually, for that, you need to understand how this training is done and how those values of parameters are basically calculated. So there is something called as the forward propagation and backward propagation. Okay. I don't know how to explain. Let
But
me.
computation power is also more required, right? So in
Exactly,
that sense,
exactly. Compute power
we cannot do
calculating.
it. We cannot do it in our own laptops or anything, I believe.
Exactly. So we can only do on our laptops, we can train very small models, right? We can download some models up to 2 GB of, I can show that also, how to download the models and train and run on your laptop itself. Okay. And then you can just disconnect your laptop from internet, and then still you can run those models. You can inference those models yourself on your computer. So what I was trying to say, okay, why do we need to, I think that that slide is not there. So what happens is when we train our model, right? So as I said, we initialize these weights randomly. W1, W2 are randomly initialized, some 0.2, 0.3. And then once I pass my first record, then I will calculate some predicted Y, and I will also have my actual Y. Yes? Are you getting, guys? With my some random initial weights, once I pass the value of input features x1, x2, x3, x4, it will calculate some value. That value may not be correct because my model is not trained, but at least I will get some value, right? It may say
Yes,
this
yes.
this is belonging to class, let's say 0. And when the very first time I say, it may say this is belonging to class 2, right? So there is an error in my predicted value and my actual value. So my aim of training the models is to reduce this error as much as possible. Okay, so when I see, let's say the error is, just for the sake of example, my error is 100. So what I will do is I will change my these W's. And there is a process of changing how you have to differentiate this particular function with the help of W, right? And then you have to see how, and then you have to equate it to 0, right? Some old mathematics of our 10th class. So we have to find how we have to change these weights in such a way that next time when I run my model or train my model, that error will come down from 100 to 90. Then I feed some more data. Then it will say, okay, now my predicted Y is something else. Now my error has been reduced. Now I will again try to change the W in such a way that my error will go on reducing. At some point of time, I will say now my error is only 5 and I am happy. Now my model has been trained. My error of margin has decreased substantially. So doing all these, needs basically storing the values of all these W's and then differentiating them and then doing second differentiation also. So that is very, very compute intensive operations. And the processors who are doing these complex calculations need a lot of cooling, right? Otherwise they will get heat up, right? If you are running, if you download anything and if you run something on the laptop, let's say Photoshop or some heavy softwares, your fan of your laptop is start rotating and your laptop get heat up, isn't it? Because it is doing a lot of processing. It is bringing the data, it is doing some calculations. So in these training models, you have to do a lot of matrix multiplications and matrix divisions and things like that. Matrix operations are done with the help of these numpys and pandas libraries. So that operations are actually very heavy, and then you need a lot of uh, GPUs to do all those calculations. And in order to cool down your system, you need a lot of air conditioning as well. Okay. So, I mean, there are actually a lot of, some environmentalists are actually opposing all these LLMs and all these things, that this is basically using a lot of powers, which is doing global warming and so on and so forth. Okay. So these models are trained. What we do, we scrape data from all over the internet, and then we clean that data and we pass that data with the LLM. We train the model. I mean, it's just like a kid. When the kid is born, we start talking in front of him, right? Khana kha le, khade ho ja, baith ja, all those things, right? So even gradually with the time, what will happen? That kid will learn whatever we are saying. Yes or no? At some point of time, it will start replying you. No, I don't want to eat. I want to go out. I want to play. Yes or no? You don't teach him very explicitly, right? But when everyone talks about, he get trained basically. So he listens so much instructions from the parents and the siblings that one day he himself will start speaking that language. Similarly, we train these models so much with the data that it understand the language, how the language is being used, what are nouns, what are pronouns, where are we using are, when I'm using ed, and it is able to understand the sentence just like human beings. We are also trained in the similar way, right? When we listen lot of things on the daily basis, we start interpreting those things, and some point of time we are also giving output, we start speaking ourselves. Same is the case with the llms. These are neural networks. When we give them lot of data from all over the internet, it start understanding the pattern and the language, and at some point of time, whatever we give input, it will be able to understand what we are trying to ask it. If you say write a resume or write a plan, it will be able to do that because it is able to understand our language. It has become proficient, right? When we learn maths, we become experts of the maths. When we learn science, we become experts of the science. But if I don't learn anything, if these models are not trained on some financial data, it cannot give you answer to those questions, right? Because it has not been trained at the first place. If you ask me some history question on which I have not studied, then I will not be able to answer it, right? Same thing happens with the models. So these models are basically trained on the lot of corpus of the data, and what they learn is predict the next token. As I said, they only know is how to predict the next best token, the best fit word from their dictionary, then repeats process until the completion. Built using transformer architecture, transformer outputs a probability distributions over the vocabulary with lots of compute powers. What are the parameters? As I said, 40 billion parameters or 100 million parameters. They are nothing but the memory of the LLM. Those are the weights basically where it will carry the pattern which it has learned, right? Whatever pattern it learns, it has to store it somewhere, right? So that once you inference your model, it will be able to use those parameters to judge what you are saying. Okay, so I will not move further. I think this is already too much for you guys. Okay, so I will just tell you what we are going to study in the next class. We will see how basically this probability works, how it is able to find what is the next best word. The chicken is crossing the road or the river or the house or the banana. Let's say it has some thousand words, then it will calculate the probability of each word. It will see, okay, this road is having the maximum probability of 20%. Then this will be given as the output. Similarly, there are some inference parameters. How many tokens you want your LLM to generate? What is top K, top P? Some settings which can influence your final output. Okay, so all these things we will see how, what is the meaning of low temperature, high temperature, how they are trained. Okay, what is pre-training? This is unsupervised. All these things we will see. How to do the supervised training. As I said, right, they are basically unsupervised plus supervised. Okay. What are the different LLM providers? OpenAI, Google AI, Anthropic, Mistral, Meta, Grok, Hugging Face. We will talk about all these things in the next class. I think we are already. And finally, what we will do, we will do one exercise where we will take some old model from the Google and we will see how it is able to answer. We will run this model. We will call it. Okay. That
Great.
will be practical session for the next class. We will do some hands-on exercise also.
Yeah.
All
So,
right. Yeah.
Surendra, one query.
Huh.
So some people used to tell actually the stats we need to go ahead with the GenAI models or AI models, right? How exactly those helpful for us? Do we really need to go through stats?
That's in the sense.
Kind of stats functions. Y is equal to f of x will be there, right? Kind of.
Mm-hmm. No,
So
I
few
mean,
people.
no, I don't think you need all those things, right? Because these models are already trained, right? Only thing you need to do is you need to just consume them. You have to call
Mhm.
their APIs and you have to tune your prompts, and you will get your output, right? Why? I mean, if you want to learn machine learning, how to train the models, I mean, traditional machine learning models or neural networks, then you will definitely need some, some statistics and some intuition of vectors and all those things. What is matrix? Just give me a second. Yeah. For GenAI, you actually don't need. That's what I'm saying. It
Okay.
was very difficult earlier to learn all these things. If you wanted to be do machine learning and you have to learn neural networks, then you had to do a lot of things. But GenAI is comparatively easier because training and everything has been already been done, right? So in today, we are not going to train our models. We just use the pre-trained models. We just need to learn how to use them for our applications.
Okay, makes sense.
Okay.
Thank you.
Yeah. Anyone else has any question?
So Surendra, like
Yeah.
say suppose like that LLM, like whatever algorithms that we have it, right? Like say suppose we have around 100 algorithms. So
Mm-hmm.
all these are like trained by the LLMs, or only the best of all those are getting trained by the LLM.
No, see, the LLM training process is a quite different, right? So the algorithms which we generally use, right, for doing all these things, earlier we were training our models for different tasks. Those
Mm-hmm.
were different, like decision tree or ADA boost, and there are lot of algorithms. So we're using those algorithms to train our models. But the training of these foundation models is not using all these algorithms. They not at all use this one. They just use the transformers architecture. This architecture they use, and we pass only the language basically. Okay. In this case, what we were doing, we were creating features. In this case, we don't need to create any features. It will itself will create features and learn from the data, right? For the housing prices, what we were doing is we were giving X, Y, Z, number of rooms and all those stuffs. And also having said that, it doesn't mean that this has finished. So there are problems, right? For example, in order to predict the price of the house, still I will need use machine learning, the traditional machine learning, the classical machine learning, not like I cannot use this Gen AI or LLMs to predict the house of my price, the price of my house. Getting?
Okay.
So they are still in the industry and they are used for the specific purpose. These are basically used wherever we are dealing with the natural language problems, where the language is being concerned, right? Text is being concerned.
Okay.
There we are using generative AI more than anything else.
So you mean to say like these will not use the random forest like AdaBoost, like
No,
whatever
no, no, no,
algorithms
no,
we
no,
not
no,
use.
no, 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 no.
Okay, got
Surendra, one question.
Mhm.
I mean, as we have multiple LLM models from different providers, right? So
Right.
how is it decided which LLM model is best suited in our case if we have to go?
So, I mean, there are various factors, right? For example, right now I am doing a project where we are doing some enrichment. So our application is going to the web and it is searching for attributes. Let's say there is a part called um, refrigeration or AC, right? Air conditioning part. Then what
Mhm.
it will do is it will go into the web and it will search what are the features, what is the input voltage, output voltage, what is the rating, and all those stuffs. So we tried Gemini, but that is not giving us the good results, right? So we have switched to the OpenAI models. So basically, it depends what kind of application you are doing, what kind of infrastructure you have. Many times, what happens is the client is already using some platform, right? Let's say they are using Azure, so they will obviously go for OpenAI models, right? If they already have invested in AWS, then they will go for some other models, right? So it depends on the use case, on the client preference as well, and sometimes you have to hit and trial. For example, for our case, when we use Gemini, it was not working well, so we switched to the OpenAI. So as per my experience, OpenAI models are the best suited. And then again, cost is also another factor, right? You want to
Yeah.
use, if you want to use,
So each model has a different costing, right?
right? Yeah, right. They have some different costing, and I mean, what you want to do basically, if you want to use vision models, if you want to analyze the images, then you have to go for some different models. Then you have to see, okay, what are the options for the vision models? What are the vision models from OpenAI, from Gemini? Basically, you have to do some homework. You have to run some samples to finally say, okay, for my requirement, this model is giving the best results. And there are some instances where actually you don't need these models. For example, if I need to read some clean images, I can simply use some OCR APIs, right? Or maybe I will use Azure Document Intelligence. That will give me the best results with the minimum cost. So overall, I need to see all the aspects: my client preference, my availability of the models, what the costing, what the use case, and then I will decide what is my model, right?
Okay, got it. Thank you.
All right. Anyone else has any questions about this session, or maybe anything in general about the course?
Just one question. So
Mm-hmm.
these models, what you said, is trained on certain set of data, right? So
Mm-hmm.
it means that anything which is not means it will not give us something which is happening just now or something like that. Means there is
Correct.
some right.
Correct. Good
Means
question. Yeah. Mm.
the idea here is that these so means they keep on coming up with these new models. I think they are training the more and more data to these models, and that's why the new version is keep on coming, right? That's what
Exactly.
is happening.
Exactly. So what is happening is, see, these models definitely have some cutoff date, right? So let's say I have trained my model, I have scraped my data, but if I'm training my model today, after 10 days, it will not have any information about the next 10 days, right? Which has passed, or whatever events which has occurred. There is a plane crash in the Ahmedabad. So the model which was trained with the data before that incident, the LLM may not have any information about it, right? So it will not be able to answer that question. But the thing is that now these models, or for example, if you ask in the chat GPT about the plane crash, it will be able to tell you, because it is not only using the LLM, but it is using some web search as well. So there is something called as the tool calling. They have couple of tools. So see, chat GPT is not a LLM, first of all. This is an application which is using LLM as just one service. So what it will do is it will use some tools, for example, some Google search or SERP API. It will search the web and it will find, okay, there is an plane crash in the Ahmedabad on so and so date. These many casualties happened. It will grab that information and then it will give it to the LLM to formulate the final answer based on the user's question. If the user has asked how many people died, first it will do some web search. That ChatGPT application I am talking about, the LLM is not yet in the picture. First, it will do a web search. Okay, there is a web search called DuckDuckGo, or maybe Bing search, or maybe Google search, SERP API. So it will do some web search with the user's question. It will get some answer. Maybe it will get answers from 10 different sites, and it will take that information and it will dump it to the LLM. Now my LLM understand the language, right? So it with that data which has been scraped from the internet on the real time, and with the question of the user, it will formulate the final answer. Okay, these many peoples have been died, these are still in the hospital, and so forth. It will draft the final answer and it will send to the user. So yes, if you talk about the incidents which happened after the knowledge cutoff, your LLM will not be able to do. But now we are creating sophisticated applications which will do a lot of things apart from LLM as well. It will scrape the data, it will give it to the LLM. I hope this answers your question. Now there are something called a reasoning
Yeah.
models also, right? We will talk more about it. What are agents? What are reasoning models? Right? They can do some deep research, right? If you see in the chat GPT, there is one option called web search. Other option is deep research. So if I say any question like, say, tell me the uh, let's say I want to know who all are working in Indian Railways who are passed out of my college. So what once I put this question, what that model will do is it will break it down into different parts. It will say what is the name of your college. So it will shoot some queries. It will do some reasoning in order to accomplish the final goal. It will break my task into different parts, and then it will execute the different searches. It will go to the different webs to grab the knowledge of my college, the name of my college, how many students have passed from my college, and how many are working in the railways. It will take its sweet time. It will take some 2-3 minutes. It will do some deep analysis, and then it will give you the final answer. So these are called reasoning models, which are basically reasoning, just like human beings. If I give you a task of writing some code, let's say, then what you will do, you will write some code and then you will test, you will find, okay, there is some error, then you will fix it, then again you will run some code, then there is another error, you will fix, then your friend will come, he will say, instead of doing calling this API, use this thing. So this is an iterative process, isn't it? This is an iterative process, and there is a reasoning behind. So similarly, they want to train the models or get the output from the models in a similar fashion. Instead of giving the answer in just one go, they want model to reason, to think about like human beings. If someone asks me how you will go to, Sri Lanka, then I may have different routes, right? Then I will reason, okay, if I take a flight, this is the cost. If I go to Bangalore, or maybe I will go to Chennai, I have to reason, right? I have to see which option is the best. For that, I have to do reasoning. Okay, we will talk more about it. But yeah, I hope this has given you some idea. Hello, hello.
Yeah, definitely.
Yeah. So I think once we have 2-3 classes, I think you guys will be able to, understand these terms and jargons and everything very easily. All right, then I will not take more time out of your weekends.
Surendra, you are sharing this recordings on a group
Yeah,
chat, right?
yeah. I will share that.
Okay.
Okay. All right then, guys.
Thank you.
Thanks everyone. Thanks. Bye bye.
Thank you. Have a nice day. All.
Thank you. Thank
You
you.
too. Bye. Bye.